Hi, my name is Barry Allman from Stackup Design. This is a quick demonstration of the iCD Stackup Planner bidirectional interface to PADS PCB design software. First of all, we'll open up a PADS database. This is a unfinished DDR2 design, but we just need to look at the stackup information in this case. Also note that the traces are all routed to 4mm width, so we want to retain that trace width when we modify the impedance. Now, what we'll do is we'll look at the layer definition, and in PADS we have top to bottom. This is a 10-layer board, and we have planes and signal layers in between. And we'll look at the thickness of the prepregs, or the thickness of the stack up. The solder mask has a 0 thickness coating, so there's no solder mask at the moment. And each layer, either signal or plane, has a dielectric of 10 in between it. So this won't give us a very good control impedance board at all, but we need to bring this into the Stackup Planner so we can run the field solver on it and simulate the impedances to get the correct values for our board. So first of all, what I'll do is I'll export an ASCII file from PADS, and we'll select all the sections and OK, and then we'll go to the iCD Stackup Planner. And what I'll do is import the PADS file that I've just created, the ASCII file. And here it is here. So we've imported the file, and as I said, the impedances are pretty wild, 93 ohms, 71, 71, 93, and our differential impedances are quite high. Now normally we want 50 ohms single end impedance and 100 ohms characteristic impedance for a standard sort of high-speed board. So what we need to do is change a few of these numbers so that we get the right values. Now if I change the microstrip thickness of prepreg here, we get 54 ohms characteristic impedance and 100 ohms differential. Looking at the strip line, I'll just change a few of these numbers here. And we get 51 ohms and 91 ohms. Now this might be fine if you want to route 50 ohms characteristic impedance and also have USB signals of 90 ohms, so that could be good for that. If we wanted to make the differential 100 ohms, we can just increase the clearance between these two traces and get 100 ohms. So this stack up could be used for USB of 90 and also 100 ohm differential DDR2 clock, for instance. Also, you should be aware of that in the Stackup Planner we can edit dielectrics and take dielectrics from the library. And if we look at that 3mm prepreg that we have on the microstrip there, we could select say an FR408 material, and if we're looking at say a 2 GHz design, which is a bit over the top for DDR3, and we want a 3mm thickness prepreg, we can just place it in here. So we can extract the information from the library and put it straight into the Stackup Planner. It can then go into PADS. So I'll just put that back for now to where it was. Another pretty cool idea here is rather than having to redo the whole stackup over again, what we can do is just do half of it and then mirror the stackup. So this creates a mirror image of the bottom of the board as compared to the top. And the only thing we need really to look at is the thickness of the actual board itself. So we need to add another, say, 12mm here, make that 17, and we get 61.1mm, which is fairly close. So there's our basic stack up. Now what I'll do is I'll rename that to new PADS, and this is our 50 ohm, 100 ohm stack up. And then what we do then is export this back into PADS. So I reopen PADS and I go to File, Import, and then I select the new PADS ASCII file that I just created, and it loads it into the PADS database. Looking again at our layer definitions, we still have our 10 layers, but looking at the thicknesses, we've now got our 0.5mm solder mask, our 3mm microstrip, and 555 strip line had before, 17mm in the center, and the mirrored stack up on the bottom. I did mention originally that the Stackup Planner takes the 4mm that we originally had our traces routed to, so we extracted this 4mm from the PADS database, and the reason being that of course we don't want to change all our routing if we're halfway through a design, so we just change the stack up and move the 4mm routing. So what we can do now is we can go into our design rules and we can select certain classes or whatever, and we can set up our differential pairs, groups of signals for match length and all that sort of thing in PADS, and route to impedance. So that's the demonstration. Thank you very much for listening.